Today, our topic is biasing circuits, different biasing circuits. Before going to that, let us briefly recapitulate what we discussed in the previous classes. So, in previous class, we talked about different stabilization techniques and different biasing techniques. Okay, what do you mean by stability? So, stability is nothing but the operating point in case of any variations in a transistor parameters such as IC0, VBE and beta. So that is called stability. So biasing circuit which provides the stability of operating point. So what do you mean by operating point? So operating point is nothing but VCE and IC. So that is the coordinate VCE comma IC. That means collector emitter voltage comma collector current. That is called operating point or quiescent point or Q point. Okay, we have to maintain the operating point always stable. We have to locate the operating point at the middle of the DC load line or intersection of AC and DC load line or at the middle of the active region. So then only amplifier circuit will be stable. If stable means faithful amplification will occur at the output side. So that is called biasing. So what do you mean by stabilization? So stabilization technique is referred to the use of resistive circuits or resistive biasing circuits which permits base current to vary so as to keep IC relatively constant. So what it means, stabilization is nothing but we have to choose the biasing resistance like base resistance, collector resistance. We have to choose certain values so that we have to maintain the output current, that is IC current is constant by it permits IB base current. So that is called stabilization technique. So in stabilization techniques, we have different biasing circuits. So we will see today different biasing circuits, okay, or different biasing methods. So types of biasing circuits. So one is fixed bias. Yes, fixed bias or base resistor method. Fixed bias or base resistor method is the first one. Second one is collector to base bias or biasing with feedback resistor. Collector to base bias or biasing with feedback resistor. Third one is voltage divider bias or potential divider bias. Voltage divider bias or potential divider bias. So these are different biasing circuits. Based on the circuit configurations, it will vary. We know that transistor symbol is it is a 3-terminal device transistor. So this one is emitter, this one is base, this one is collector. So by using this transistor, we have to connect the resistance like collector resistance, base resistance, emitter resistance. Then we will maintain the output. So left hand side is the input, right hand side is the output. We know that. So we have to maintain the output. What is the output? So here collector terminal, this one is emitter terminal, means voltage is VCE voltage here and current is IC current. So this is the operating point. So Q point. So Q point is nothing but VCE comma IC is called as Q point. Okay, we have to maintain by applying the zero base signal. Okay, that is called biasing. So some important points to be analyzed in biasing circuits. So you have to remember these points while deriving the stability factor in biasing circuits. So these points are common to all biasing methods. So first one is every biasing circuit, every biasing method, there is a circuit. First one is circuit diagram. Okay. So whenever circuit diagram is there, what the next step? Understanding the type of configuration. Understanding the type of configuration and note down the input current. Just I discussed. So left hand side is the input, right hand side is the output. We have to note down the input current and input voltage, input current, input voltage, then output current, output voltage. So that is the second step. So third step means find the expression for the coordinates of operating point. So what is the coordinate of operating point? Coordinate of operating point is output voltage. This one is the output voltage and output current. What is the output voltage in transistor? So it is a common emitter transistor. Output side is output voltage is VCE. So this is the emitter terminal. This is the collector terminal, means VCE, and output current is IC. So operating point here VCE comma IC is the operating point. So find out the expression for the coordinate. So this is coordinate VCE comma IC. So this bracket indicates one coordinate. So two values. Okay. Next, apply the KVL. What do you mean by KVL? Kirchhoff voltage law at the input side and find the input current. What is the input current here? So IB. IB is the input current. IB means base current. Next, so use the input current, that means IB, and amplification factor beta to find the output current. So by using the input current and amplification factor to find out the output current. So that is the next step. So last step is apply KVL, Kirchhoff voltage law, at the output side and find out the voltage. See here we are applying two Kirchhoff laws. One is input side and other is output side. Two times we are writing the KVL equations in any biasing method. Okay, so these steps are common for all biasing circuits. So I repeat, one is circuit diagram, understand the type of configuration, which configuration it is, and note down the input current, input voltage, output current, output voltage. Next, find out the coordinate of operating point VCE comma IC. So apply the input KVL and find out the input current. Apply the output KVL and find out the output current. So these steps are common for all biasing methods. Okay. So first topic is fixed bias or base resistor method. Why it is fixed bias? Why we are calling base resistor method? You will come to know. See, this one is the fixed bias circuit. This one is the fixed bias circuit. So we know that this is a transistor. This is a transistor, is a three-terminal device. So one is emitter, this one is base, this one is collector. But transistor is a two junctions. So first one is base emitter junction, other one is collector base junction, two junctions. See, left hand side is the input side. So this one is the input. This one is the input. This one is the output. So right hand side is the output. So the circuit first identify as per the steps. So circuit is given, see here. So circuit we have. Next, what is the step? Understanding the type of configuration and note down the input current, input voltage, output current, output voltage. See, what is the input current here? So this is the input side, means input current is IB. So this is the base terminal. So base terminal means we have base current. So IB is the base current or input current. What is the input voltage? So left hand side is the VBE. So base emitter voltage. So base emitter voltage is the input voltage because it is in left hand side, input side. Base emitter voltage is the input voltage. Now we come to right hand side. So in right hand side, IC. IC means collector current. So collector current is the output current. What is the output voltage? So right hand side means output voltage. So this terminal voltage VCE. So VCE is the output voltage. And find out the coordinates. Operating point means we know that operating point means VCQ comma ICQ. Q means Q point. So we also called as operating point, or operating point can be operating point can be called as Q point or quiescent point. So Q point or quiescent point. Okay. So these are the second step. So first analyze the circuit, which configuration. See, you can clearly analyze. So one resistor in a common emitter terminal, one resistor in a base terminal. But this resistance RB is nothing but base resistance. Base resistance is connected to VCC, means supply voltage at the collector terminal. So base current is directly base resistance is directly connected to the base terminal. Okay, this RB has high value. Base resistance has high value. So whenever zero signal, that means we are not applying any signal to this circuit, this battery will provide a signal or voltage to flow the base current to the transistor and maintain the IC value. Okay, and maintain the IC value. So whenever we are not applying any AC signal, at that time this battery gives the voltage to this transistor, so that current is flowing, base current is flowing through transistor and maintain the IC value. We know that IC value means IC is equal to beta IB. IC is equal to beta IB. We are not applying any input, means it is a fixed value. Beta is the fixed value. Okay, IB means because of this battery, some current will be flow in the transistor. So beta value and IB, we will get IC current. Okay. See, next step is apply the KVL at the input side. We know that. So we have to write the KVL. So KVL to the input side means, so left hand side is the input, means KVL is like that. So KVL. So this is called KVL path from VCC. VCC minus KVL means I wrote here VCC minus. So this point. Next point is IB RB. Next point is VBE. So VBE is equal to 0. This is called KVL equation at the input side. We know that. So this one is the voltage. So current into resistance. This one is the voltage. Here also VBE, base emitter voltage. See, three things, voltages. So that's why it is a KVL equation. That's why it is a KVL equation. Okay. So this is input KVL equation. From that we can wrote like this. So VCC is equal to IB RB plus VBE. Okay, from this equation. So same thing here. See, VCC minus IBRB, VCC minus IBRB minus VBE is equal to 0. So this is the battery voltage. This one is the base current and base resistance and a base emitter voltage. So from the above equation, we wrote that IBRB is equal to VCC minus VBE. So from this equation, we wrote IB is equal to VCC minus VBE by RB. So this is the base current whenever we are not applying any input signal or input AC signal. So IB is equal to VCC minus VBE by RB. So you can clearly observe in this equation, VCC is a fixed value. We are giving some battery. So VBE means battery base emitter voltage. That is also fixed. RB is the resistance value. This is also fixed. So everything is fixed here. So that means IB depends on RB. That means IB is inversely proportional to RB. Okay. So we know the basic formula for common emitter. So we know that common base amplification factor is alpha, common emitter amplification factor is beta, and a common collector amplification factor is gamma. So it is a common emitter means beta. So beta means IC is equal to beta IB. So collector current is equal to beta times IB, base current. So this is the input side. Okay. So collector current is equal to beta into IB, this value. Whatever the value we got multiplied with beta, we will get collector current. Okay. Next one is apply KVL to the output of the circuit. What is the output of the circuit here? So apply the KVL to the output side from here to ground. So right hand side KVL is first VCC minus ICRC minus VCE. I wrote here KVL for the output loop, VCC minus ICRC minus VCE. So is equal to 0. So this is the KVL for the output loop. So this is the voltage. So current into resistance. This is the voltage. This is the voltage. So it is a KVL equation at the output side. So same thing I wrote here. VCC minus ICRC minus VCE is the KVL equation at the output side. From this equation, VCE is equal to VCC minus ICRC. Okay. So from this we got the VCE value. Here we got the IC value. So Q point is VCE comma IC. So Q point means VCE comma IC. We are calling Q point means VCEQ comma ICQ. So this is called Q point or operating point. Okay. So we know the stability factor formula. S is equal to 1 plus beta by 1 minus beta into dou IB by dou IC. We know this formula. It is the basic stability factor formula. So stability means it varies from 0 to 1. If stability factor is nearer to 0, it is more stable. If stability factor is near to 1, it is unstable or unfaithful. Okay. So from this we can derive partial derivative. So dou IB by, we know the IB value. We know the IB value here. See here, we know the IB value. So IB value I wrote here. IB is equal to VCC minus VBE. So IB is equal to VCC minus VBE by RB. That means we have to derive. So dou IB by dou IC with respect to collector current. What happened? Dou IB by dou IC means it is VCC is the constant, VB is a constant, RB resistance value constants. So differentiation, partial differentiation of constant is equal to 0. Okay. So from this equation, S is equal to 1 plus beta by 1 minus beta into this one is dou IB by dou IC is equal to 0 into 0. That means beta into 0, 0. So 1 plus beta by 1. That means S is equal to 1 plus beta. So stability factor is equal to 1 plus beta. So we can clearly says that it is unstable because stability factor is nearer to 0 means it is stable. Already it is 1 plus beta, some parameter. So stability factor is more than 1. That means it is unstable. So why it is fixed bias? So we are talking about fixed bias analysis, but why we are calling it is a fixed bias? So why means see, this is the VCC, this is the VB, this is fixed, this is fixed. All parameters are fixed here. That's why it is a fixed bias. So one reason why it is a base resistor method. Why it is base resistor method means we are connecting the resistance, RB resistance to base from VCC to base. That's why it is a base resistor method. Why it is fixed bias? IB is equal to all values are constant. VCC battery voltage, junction voltage, base resistance. Both are fixed values. That's why it is a fixed bias. But stability factor is more than 1 plus beta. Beta have some value from 20 to 500 in common emitter. So beta varies from 20 to 500. For example, S is equal to beta is equal to 20 means how much? S is equal to 21. So it is unstable, but circuit is very simple. So this is called fixed bias. This is called fixed bias or base resistor method. Okay. Now we will see advantages of fixed bias or base resistor method. What is the advantages? This is a simple circuit which uses very few components. Few components means we are using base resistance, collector resistance. That's it. That's why it is very simple. The operating point can be fixed anywhere in the active region of characteristics, simply changing the value of RB. Thus, it provides the maximum flexibility. So in this, we are only changing the RB value. If RB value changes means Q point will change. That is the advantage. So simply you can move the Q point in active region anywhere by changing the base resistance value. Okay. What are the disadvantages of fixed bias or base resistor method means? With the rise in temperature, the operating point is not stable because because of temperature, beta value change and IC value change and VBE value change. These three things are there in fixed bias. If temperature is changes means Q point is the temperature changes means this parameter also change. If parameters change means Q point is also change. So if temperature, it is unstable for temperature. So when the transistor is replaced by another with a different value of beta, the operating point will shift. That is, the stabilization of operating point is very poor in fixed bias. So when temperature is increases, there is instability. If transistor is replaced by another transistor with a different beta value also, this operating point may vary. So that's why fixed bias is not suitable because stabilization factor is very poor. That's why we are not preferred in any amplifier circuits. Fixed bias, even though it is simple, but stability is very poor. Very poor means there is at the output side, amplification is unfaithful, means some distortions, some information will lose at the output side. That's why this fixed bias or base resistor method is not preferred in amplifier circuit. Okay. So this is the fixed bias circuit. Okay, are you understood? Okay, let us summarize what I discussed, what I teached in this session. So generally, we have two things. One is stabilization techniques and one is biasing techniques. So stabilization technique means what? By use of resistive bias circuits with permits IB and vary the IB current and maintain the IC value. That is called stabilization. What do you mean by biasing? So biasing circuit provides the operating point in the use of variations in the transistor parameters. Variations in the transistor parameter means IC naught, means reverse leakage current, beta amplification factor, and VB. Okay, so to maintain this output current IC, we have to use some different biasing methods. One is fixed bias or base resistors method. Other one is collector based method. Third one is voltage divider method or feedback method. Okay, in fixed bias method, one base resistance is connected to battery VCC to base. That's why it is a base resistor method. It is a very simple circuit. First, we have to write the KVL for the input and the KVL for the output. We have to find the Q point. Q point means VCC comma IC. Okay. So here base current consists of VCC minus VBE by RB. That means VCC is a fixed value, constant value. VB is also constant value, and RB also resistance value is also constant value. That's why it is a fixed bias. So what is the stability factor formula? S is equal to 1 plus beta by 1 minus beta into dou IB by dou IC. That means differentiation of IB. We know already IB is equal to VCC minus VBE by RB. So different every parameter VCC, VBE, IB constant. So every parameters are constant. So differentiation of constant means 0. So we have to substitute dou IB by dou IC is equal to 0. We will get stability factor S is equal to 1 plus beta. So if stability factor is nearer to 0 means it is the more stable, else it is unstable. Okay. Okay, thank you.